I'll have this, or a version of this, depending on which one of the classes kind of works out best, is I'll have at least one of these online, where if you're going back and looking at stuff later tonight or in the morning, and you're like, now how to do that again, it'll be there available for you. So I'll just open it up for questions now before I start giving my 2 cents worth more on things. Is there a particular question you want to start on? Because again, that sheet you picked up today, hello, I just became important. I'm just going to start writing down numbers.
On all of them? Like, I didn't get any of them right besides 2.
Oh. Okay, we will take care of that.
4, 5, 6. And then I have 5, 6, 7.
Like I say, right now 4 through 7 is where we would start. And then we'll bounce around. We're probably going to get to everything anyway. Okay. Let's start at 4 through 7, then we'll work from there.
Actually, can we start at 3?
Okay, now, I have a feeling, and I'm going to kind of put my 2 cents worth in on where people tend to get messed up on some of these, and we'll see if that applies for some of you. On 3, I would hope most of you would realize, well, it's like a proportion, so I'm going to cross multiply. Here's where people tend to get stuck. And I know I've mentioned this before. Whenever you're cross multiplying and you see binomial terms, they have a plus or a minus there, you've got to put those parentheses in because you have to distribute the value through. In other words, here, this 8's going to distribute through the x minus 3. The 3 is going to distribute, oops, thank you. Make sure we get the detail in there good. And now at this point, I'm going to distribute through and go ahead and just solve this. So again, I've got x terms on opposite sides, so I can choose which side I want to move them to. And then I'm just going to finish this one off. But the whole key there is, oh yeah, got to make sure I distribute. So if I don't, it's kind of ugly. Okay. So here again, same thing kind of applies. I want to get my variable term alone first, if possible, before I start trying to deal with getting rid of the fraction. And again, some of you here take this on different ways. I like taking this on by multiplying by the reciprocal, because I can knock that out in one big swoop. And then I just remind myself, oh yeah, when I get to the 6, it's multiply times the top, divide by the bottom. 6 times 4 is 24, divided by 3 is 8. And if some of you on this one, you go through and multiply by 4 first, get an answer, and then divide by 3, that works. Oh, okay.
Wait, do you have any other ways that we can do it? Because that confuses.
The only other thing that I would possibly suggest here is if I didn't want to go that route, my first step would still be the same. I still would get to here. But if you wanted to kind of slow things down a little bit, we always could get rid of the fraction part first and just multiply by the 4, which would take care of this. And then just divide by the 3. So I'm doing the same thing as I do with the reciprocal. I'm just taking one extra step to kind of slow things down a little bit. And that's fine. But those would be the 2 routes I'd go.
And then you got the 4 because that was on the bottom, right?
Yep. Yep, just my way. I'm just doing an opposite. So instead of divide by 4, I multiplied by 4 there. Okay? So then, though, let me get back to 4 here. 4 is a little bit of a dandy, but we're going to do it the same idea. We talked before about when we have different denominators here. We want to multiply through by our common denominator so we can work. And some of you are like, well, I'm not sure. So the suggestion I'd made was, if you're not sure, take each unique number down in the denominator, multiply them together, so 7 times 3 is 21, and that's what we're going to multiply by through. Now here's how this works. We multiply what's on top and then divide by the bottom, and it's all the way through. So like for instance here, okay, start with my first term. 21 times 2r would be 42r, divided by 7 is 6r. It's always multiply by the term on top and then divide by here. So here's basically what I'm doing. Let me do a little side work so some of you can see what I'm up to. I'm doing 21 times 2r. Okay, so that's 42r on this first one. And then you always divide by what's in the bottom of your fraction. And I'm going to do that for each one of these terms all the way through. So on this next one, I've got 21 times negative 3 is negative 63. But then I divide by what's on the bottom of my fraction. And I'm going to keep doing this all the way through till I run out of terms. 21 times 3 is 63, divided by 7 is 9. And one last time, 21 times negative r is negative 21r. But now my fractions changed. Now I'm dividing by 3. It's negative 7r. Because if you went to find a common denominator and tried to keep all this as fractions, you're going to do all this work anyway, but you're going to have fractions on top of it, which is why I'm usually not a big fan of doing it that way. It's just easier to multiply through. So once I've done that, then I can go through combine like terms and actually solve this. And I'm wondering if the other thing that might have gotten some of you is when this happened. You're like, wait a minute, negative 9 plus 9, wait, that cancels. So all I've got left is 6r equals negative 7r. Something must have gone wrong. No, it hasn't. I'm going to get all my r's together on one side so I could add my 7r over. And I'd still have 0 left on the other side, which I can still solve for. Because I can still divide by 13, and I can get an answer of 0. But again, and the same thing as far as setup goes will be what we're going to do on number 5. Now, if some of you recognize right away and you say, well, wait a minute, if I was trying to find a common denominator here to be 4, because that would be the smallest number that goes into both, awesome, go with it. But some of you are, I'm seeing already, are creatures of habit. You want to be able to do the same thing as often as you can, and that's okay. So if we're going to go that route, you'd say, okay, I'm going to multiply these because they're different numbers. 4 times 2 is 8. Well, you mean I can multiply by 8 or 4 and get the answer? Yes. The 8's going to make the numbers a little bit bigger, but the idea still works. Either one works. But some of you, if I keep going back and forth between least and then multiplying, it's going to be, wait a minute, what? What? So yeah, 4 would absolutely work. So, but just like what we were doing before, I'm going to multiply by the number on top, divide by the number on the bottom. So for instance here, I could do 8, or if you did 4, 4 would work. 8 times 3 is 24, divided by 4 is 6. 8 times 5 is 40, divided by 2 is 20. And yes, even though this isn't in a fraction, I still multiply through. 8 times 13 is 104. And then I just simplify what I have left. And it even goes in nice. I don't even get a fractional answer. And again, it would work with 4. All these numbers would just be half as much. You'd end up with 3x plus 10x equals 52, and you'd get the same answer. Yeah, it's just getting used to dealing with the fact that fractions aren't that big of a deal. That becomes our biggest issue there. So you're like, oh, that's what I should have been doing when I was doing the homework. Okay. So then down here on the bottom was 6 and 7. Now again, isolate the equation. And I'll also say this, again, not trying to be mean-spirited, but when we get to ones like 6, 2 straight days we've been doing the same types of ones. I'm wondering sometimes with some of you, if you're going back and looking at your examples or notes, or if you're just saying, I can't do it off the top of my head, screw it. You've got to get out of that habit. Because here, I'm looking at it and I'm going, well, wait a minute, I'm solving for L, okay. I only have one L here, so it's not like I have to do the factoring thing. I don't have to take the 2 out here. I'm not trying to solve for the 2, I'm trying to solve for L. So whatever's not with my L term, 2W, needs to go away. And for some of you, it's just the idea still that we got multiple variables working. And I get that too. But we're still going to treat it just like we would treat any other equation. Okay? My goal is to get L alone. Whatever is not with L, multiplying by 2, needs to go away with an opposite. Now some of you may notice, and you're looking over at the board right now and you're going, well, over on the board you have P over 2 minus W equals L. Well, what's up with that? These are the same thing. You're like, well, how's that? Well, if I started to break these up into separate fractions, and I don't have to, this is perfectly acceptable, but if I did, I'd have P over 2 minus 2W over 2. Well, P over 2 doesn't reduce, and I see that, but here, these each have a 2, and they'd cancel, just leaving me with the W, which is why I can write this either way, and it's the right answer. So if you had this, I hope you didn't erase it looking over there and thinking, oh, this is, no, you just have to take a minute to see what form it's in. So either one of those, perfectly peachy. And I'm wondering if the same thing may happen to some of you on number 7 here. Number 7, I'm going to treat kind of like what we did in number 1. Because if you notice, back at number 1, I had a fractional term, and then I had something that was added or subtracted to it, but I wanted to solve for the one that had the fraction. So if I use that as my example to do number 7, I go, okay, there's what I want to solve for. I don't want the 32 here, so I'm going to minus that out. Now, depending on how you do it, some of you are comfortable with reciprocals, like I did the first way in number 1. You're going to multiply by 5/9, you're going to be done. So we'll do it both ways, kind of as our review here. If you don't mind reciprocals, this is going to go really fast because those will cancel, and I'll get C equals 5/9 times F minus 32, and I'm done. You're like, oh, that's not bad. But again, if the whole reciprocal thing doesn't work for you, and sometimes it doesn't work for everybody, and that's okay, here's what my other option's going to be. When I get to this step, because I'm still going to minus the 32 first, I'm going to do just like we did in number 1. Okay, I just want to get rid of the fractional part first. I want to get rid of the 5. I'm going to times by 5. Okay. Now here I even have a choice, but we'll talk about that. At this point, I'm perfectly fine if you just divide by 9, circle that and call it a day. You're like, but that's not what you have up there. That's true. Because if you wanted to, you could have distributed up here. You're like, so really there's like 3 different answers I could have for this? Yeah. Any one of those 3 are all equivalent. They're all the same thing. So depending on what your use is for it, any of them work. So again, it's taking that time to really take a deeper look at your answer and say, ooh, is this really working? Yeah, this really is the same answer. Okay. And not just say it's not exactly what he has, it's wrong. That's not always going to be the case. So then, of course, just to make sure, you flip over here. Because I know they're new, so I want to make sure we're okay on the back here. So on the back, this is more the one that if people would have been right away like, I'd have been like, wait a minute. This is exactly like what we've been doing for 2 days. Solve for H. Oh, crap, there's 2 H's. H can't be in the answer. We need to get down to 1 H. So remember, they each have an H in common. So what do I have left for my parentheses then? Well, H times what gets me to 2H?
2 plus R.
2, right, plus R. Okay, did the distributive property backwards. Did a little factoring. But now, I have 1H. That's pretty slick. Except for the fact that I put a hole in my paper. Because that all cancels out and just leaves me with what I need to solve for H. So it really does go quick. I've just got to recognize I can't have 2 H's here. I can only have 1. I have to factor. And then we always have to put in one easy one and one that might have a little more complexity to it. Okay, here, write an equation. All you have to do. Fee plus ride equal cost. Now, do you have to do that? No. If it helps you to actually make the math equation you need to do it, absolutely. A fee you pay at one time. I pay $6 to get in the fair. Doesn't matter what I do once I get in there, I'm paying $6. It doesn't get a variable. $2 per ride. Okay, if I go on 10 rides, that's going to make my cost different than if I would go on 3 rides or 6 rides. But that's all I need. Again, don't make life complicated. And then the last one's simply going to be, can you plug in? Give you the formula. I earned $19.25 in interest. That's my I. How much money did I originally deposit? So that's going to be my P. So $19.25 equals, I don't know P. How do I write my interest rate as a decimal? How do we do 3.5% as a decimal? Yeah, 0.035. Or I can divide it by 100 if I'm not sure. And then it says in 1 year. So my time is 1. And it simply is going to be a one-step equation. And be careful when you're hitting divide that your decimal point ends up in the right place. But if I divide by 0.035, scooch this up a little bit. And my P, I remember, no, I don't remember, 550, yes. Means I had $550 in the account at the start of the year to earn that much interest at that rate. Okay. Quiz tomorrow, basically, you see, is going to look like this. Of course, the numbers are going to be different, stuff like that. But otherwise, same thing. Okay? If you